Okay, everybody good with this part?
Yeah.
Great. All right, we're going to proceed on down. And we're going to look at Chevy Chevs. Ooh, Chevy Chevs is good. Okay, Chevy Chevs is just fun to say in general. Brian, go ahead and read for me. Chevy Chevs.
Chevy Chap's theorem. The proportion or fraction of any set of data lying within k standard deviations of the mean is always at least 1 minus 1 over k squared, where k is any positive number greater than 1. For k equals 2, at least 3/4 or 75% of all values lie within 2 standard deviations of the mean.
Right, so pause for a second. Right, so when k is 2, that means we want 2 standard deviations. K stands for how many standard deviations. So 2 standard deviations means that 1 minus 1 over 2 squared, because 2 standard deviations. What's 2 squared? 4. 1 minus 1/4. 1 minus 1/4 is 3/4. So 3/4 of the data is going to lie within 2 standard deviations. Keep going.
For k equals 3, at least 8 out of 9, or 89% of all values lie within 3 standard deviations of the mean.
Right, so 3 standard deviations means 1 minus 1 over 3 squared. 3 standard deviations, 3 goes right here. So what's 3 squared, everybody? 9. So 3, 1 minus 1/9 is 8/9. So at least 8/9 of your data is going to lie within 3 standard deviations. Chevy Chevs is powerful for a couple of reasons. One, the most important reason is because it applies to any set of data. It doesn't have to be normal, it can be any set of data. You can even make up numbers, and Chevy Chevs will apply if you find the mean and standard deviation of it. On the other hand, even though it's very powerful, it's not very accurate, right? It gives you a big range. So at least within 2 standard deviations, at least 75% means it can be anywhere from 75% to 100%. That's a pretty big range. It's like saying, well, yeah, I mean, it's 75% to 100%. That's a pretty big range of possibilities. That much data can fall within there, anywhere between that. Within 3 standard deviations, 8/9 falls within 3 standard deviations. What you're going to find is more commonly within 2 standard deviations, it's going to be more like 90% or 95%. It's going to be a lot more than 75%, but at least 75%. That means 75% or more. And what we're going to find with 3 standard deviations, it's going to really be a lot closer to like 99%. But it says, well, 89% or more. Right? It gives a bare minimum. All right, so what does this look like visually? It looks like this. Here's my mean. If I go 2 standard deviations this way and 2 standard deviations that way, then between these 2 values, at least 75% of my data is going to lie between those 2 values. If I go 3 standard deviations this way and 3 standard deviations that way, then between these 2 numbers, then at least 88.9% is going to lie between those 2 numbers. That's what it means. So what you guys need to do is, your example, IQ scores have a mean of 100 and a standard deviation of 15. What can we conclude from Chevy Chevs? Okay, well I gave you a little bit of some hints already. I think I said at least blank of these, so you can either use a percentage or you can use a decimal, a fraction or a percentage, will lie between blank and blank. What we're asking you to find are, oops, what happened? What we're asking you to find are these values here. Right, find these values here. So you know that at least 75% is going to lie between these 2 values. What are these 2 values? So I'm going to take a couple minutes. So I'll give you a hint. The first blank is at least 75%. Lie between blank and blank. You got to figure out what blank and blank are. Good? Yeah, I would draw a picture, guys. So what I would do is I would draw a line, probably. Put your mean there, and then figure out what you got going on, right? Within 2 standard deviations. Where is that? If you're at home, pause this until you finish this problem and then start again. Victoria has the way she likes to kind of think of it, if you want to talk about that. You guys quiet?
So when it's saying that like it's within like 2 standard deviations, if I'm standing here in the middle and say like if I take 1 step, that's 2 feet. I'm taking 1 step, that's 1 standard deviation, and 2. I have moved 4 feet because 1 step is 2 feet. And then in the other direction, it's the same exact thing. I'm taking 1 step and another in the opposite direction. Like a number line. I'm moving
So this is like,
an equal distance each way.
so in this situation, you should be taking like a step of like 15 inches.
Yeah.
So 15 inches one way, and 15 inches again, another step, 15 inches, right?
Yeah.
Perfect. So yeah, that's a good way of kind of thinking about it. Is think of every standard deviation as being like a step, right? So 2 standard deviations take 2 steps this way and 2 steps the other way. So I like to draw my little pictures. 2 steps this way, 2 steps that way. What are these numbers here and here? Yep, 70 and 130. If you go 3 standard deviations, 1, 2, 3, 1, 2, 3, you get to 55 and, yep. So these are your answers. If you could have said 3/4 instead of 75%, you could have said 8/9 instead of 88.9% or 89%. Any of those are fine. 89%, 88.9%, 8/9, all the same, all good. Okay. Thanks. All right, so let's talk a little bit about normal distributions. Diego, you want to read for me?
Yes, normal distribution. Do you remember a couple of days ago when we worked with histograms and showed one that approximated a normal curve?
Right? It looked like this is that bell curve. So here are, here's the thing. If your data is in that bell curve, if it's approximately normally distributed, then we can do better than Chebyshev. Right? So for that group, we can do better. Chebyshev says for 2 standard deviations, then at least 89%. So between 89% and 100%. Oh, sorry, 2 standard deviations, 75%, at least 75%. So for 2 standard deviations, between 75% and 100% will fall within 2 standard deviations. Empirical rule, if it's normally distributed, then it's going to be about 95%. That's a lot more accurate. Instead of saying anywhere from here to here, we're saying it's right around there. Right in this area, not anywhere in this range. Right? It's right in this area, so it's a lot more specific. Chebyshev also says within 3 standard deviations, at least 89%. So anywhere from 89% to 100%. Empirical rule says if it's approximately normally distributed, it's not between 89% and 100%. That's this big range. It's right around 99.7%. That's a lot more specific. It's not saying anywhere between these things. It's saying right around this spot here. And Chebyshev doesn't say anything about 1 standard deviation. Basically, it says 100% of your data, anywhere between 0 and 100%. So that is basically saying nothing. Empirical rule says right around 68%. Right around that. You're right in that range. So the empirical rule, again, only applies to normally distributed data, or approximately normally distributed data, but it's a lot more specific. Here's an example. Oh, wait. That's not right. We're going the wrong way. Here's it pictorially. I bet. There we go. So it's saying that within 1 standard deviation of the mean, here's my mean. If I go 1 standard deviation away, then at least 68%, about 68%, not at least, about 68% will fall within this range. If I go 2 standard deviations away in either direction, then right around 95% are going to fall between these two values. And if I go 3 standard deviations away, then between these values here, right around 99.7% will fall between those two values. So that's what the empirical rule says. It's a lot more specific. Yeah?
So it says for normal data, what counts as normal data?
Ones that I tell you, assume it's approximately normally distributed, that data.
Yeah.
Yeah. So, well, the good thing is a lot of data is, there's a fair amount that's approximately normally distributed.
Okay.
But yeah, we're gonna deal, most of what we're gonna focus on is data that's approximately normally distributed.
Oh, okay, cool.
Yeah, question?
Do we need a TI-83 calculator for the exam?
Yes. So, starting next week, you have to have a TI-83 or 84 calculator for your homework. In class, you could use these ones on the computers. That's okay. For your homework, you're going to need one. You can install one on your phone if you like, or you can do your homework. You know, at any of the computers on campus, those will have these TI-83, 84 calculators on them as well. You can borrow them from the library for the semester. For the exam, obviously, you can't use a computer or your phone, but I do have, I think I have about 10. I need to get them back to back from the library so I can have them for exams that I can loan out to people for exams. But yeah, there's an app on your phone. If you have an Android, there's a free app on your phone you can use. The Wabbit one that's on the computers, you can use that on your phone. Talk to me because I can help you set it up. For an iPhone, so you have to buy an app. I think it's like $3 or something like that. The other thing you can do is you can also buy them on Craigslist. A TI-83, a used TI-83 on Craigslist is like $35. And then at the end, when you're done, you can sell it back on Craigslist for like $35. So it's a little bit of work, but it won't cost you anything if you buy it and then sell it back, right? So it's another possibility. Okay. All right, so now, so now you guys need to do a similar thing. We know our IQ scores have a mean of 100, standard deviation of 15. Fill in these blanks, where they should go. It shouldn't take, I will give you 4 of them you know already. So I'll give you guys 30 seconds to fill these in. Fill them in. If you're at home, pause the camera until you finish this.